Okay, we said 5 past, so I'll kick it off if you're ready. I'm Tony Brown. Welcome to my lecture. I'm a chartered quantity surveyor by background. I probably don't know what quantity surveyors do, but it's a critical part in the construction industry in the UK. I'm a member of the Association of Cost Engineers, and I joined that for a time when I was working on in oil and gas. And I'm a regional director with my company Faithful and Gould, which you probably haven't heard of. It's part of the Atkins group. Some of you might have heard of Atkins, WS Atkins, and Atkins are probably going to be taken over by SNC Lavalin, a Canadian company who are about twice the size. So times are changing. So I've worked in the northeast a lot of the time, but currently I'm a commercial manager on the new build nuclear power station down at Hinkley Point. So you know, I fly down to Bristol early Monday morning and come back Friday night. So today's a nice day for me, okay, nice early finish. My wife will be pleased to see me, I'm surprised that she is. So I get to talk to you on this subject, cost management and construction strategy, and I also get to set one question with multiple choice. You don't have to answer the question that I've set, but there is one question based on these notes, and you don't really need to do any more reading other than the notes. The answer will be in there. I've put my contact details there. I've got some business cards here if anybody wants to get in touch with me, but you've hardly got any time because I think the exam's early next month.
Yeah.
So, yeah. So I'll start as we do in all our meetings when I'm working on site with a safety message. So if you turned up at a construction site, what would you expect on arriving on the site?
Induction.
You'd expect an induction. Anything else? Part of the induction?
PB.
Yeah. Anything else? Problem with inductions on construction sites is construction sites are work in progress, so they always change. So in the early days, there's lots of holes in the ground that you can fall into. So later on, there's objects falling from height, so it's got to be relevant. That's the sort of thing I've put, and there's not a right or wrong answer to this. You go via a control gate. I've been on lots of pipeline jobs where, by the nature of the job, it's stretched out, and they don't have the site secured. It's absolutely unacceptable, and somebody will be prosecuted for that. So you need to enter via an approved gate. You should be directed to the site office by a safe route, and often that's painted green on the floor so that you don't wander off. Be introduced to the person in control of the site, or somebody's going to give you the induction. You should be asked if you've got a current construction site safety card. You're all aware of them? Has anybody got one? Yeah, just last year when I mentioned it, there was 3 of the students had gone off and got themselves a CSCS card. Not that easy to get these days, but they do control them. Should be given specific induction where the risks are identified to you, and the induction needs to be relevant to the work you're going to do. So if you're just visiting the site office, it tells you, what the fire alarm sounds like, what happened if there is a fire, where to sign in and things like that. If you're going to do work on the site, you need to understand the control methods. You should be expected to have and to wear personal protective equipment, and that's to a specific standard, and be required to sign to confirm that you've read and understood the instructions and been instructed. Just on PPE, there was a time when I was working in the chemical industry when I had to carry 3 different kind of hard hats because of the specific requirements. There's a set of notes if you want to pick them up as you go past. Is it too late? So in terms of introduction, this is what I'll be talking to, the process that we go through in controlling construction projects. So we identify the project scope and identify the strategy for delivering it. It's important that work packages and cost breakdown structures are identified so that we're working in a consistent approach across the different trades. Plan and schedule the work and prepare an estimate, understand the risks, and then as we move into the delivery stages, the later stage of the project, we manage change, we manage the costs, we manage the progress, and we report on that. So everything that I tell you should come back and fit into one of those boxes. Not the only thing, of course, there's lots of other activities going on, and this is where some of the confusion arises, because design might be off doing their own things. That's not in accordance with the programme or in accordance with the estimate, or they tell you they've completed the design when in fact they haven't. The engineering aspects. Regulatory, mentioned that particularly strong in the industry I'm in the nuclear sector. Everything has to go through the Office of the Nuclear Regulator and be approved by them. In pipelines, it's usually the health and safety executive. But you can equally end up with insurers wanting to specifically have overview of what's been designed and what's been delivered. Statutory undertakers, local community is a big one. Used to just ride roughshod over them, but these days there's a lot of effort put into them. Finance, how are you going to finance the project? The bankers and the finance houses may want an input into the project. Document control is a big issue. I had a specific issue, again in nuclear, but on the existing power stations. You know, I think it's 6 or 7 advanced gas reactors that are operated in the UK. They did some inspection works and they found that one of the turbines had a stress fracture on the blade. So they started to look at what standard it was built to, and they couldn't find the drawings. Now they've got about 80 of these on the 2 power stations, 2 sister stations, and they're going to have to take it to pieces and reverse engineer it because they couldn't find the drawings. It's probably going to cost them upwards of £50 million. And they did get a lucky break on this occasion. They went to a care home and found an 80-year-old retired engineer who had early onset Alzheimer's, and asked him about how the turbines had been designed. And he said, oh, but of course, if you go to my house, there's a shed at the bottom of the garden, and there's 3 tea chests in there, and I've got all the drawings and all the specifications for the turbines. He said, well, why did you keep them? He said, well, they were too good to throw away. I got told to burn them, but I kept them. Saved them a fortune. So document control, everything you build, everything that goes under the ground, we need to have good records of it, and that's especially true of pipelines. Where they are, what standards they were designed to, what standards they're manufactured to. Does not happen. I think he's. Sorry, you say something, or? No. Sorry, I just thought you. Public relations, obviously, labour and trade unions. A lot of big organisations and pipeline jobs included will have an IR department that deals directly with the trade unions and the operatives to try and stop strikes and lockouts. And if you follow the local news down on Teesside, you'll know that every Friday there's a dispute that goes back many years, and they're trying to blockade the sites down there. And that's just going on and on. Procurement, are we going to procure the various contract packages? Legal and legislative constraints, I won't go through them all, but there's a whole lot of other considerations that need to be taken in, and they're often different trades, and importantly they can be from a different organisation. So they won't know how the processes work together. So it's important that you document how everybody's going to work together so there's a common understanding. So the main commercial bits, the bits I'm going to talk about, which are addressed in any programme works, are estimating, planning and scheduling, cost control or cost management, change control and risk management. They're the main drivers. They're generally referred to as project controls, as distinct from project management. And you quite often get a conflict between project controls managers and the program managers or the project managers. But if you document who's going to do what, it shouldn't happen. One of the reasons it happens is because if you're measuring progress and reporting on costs, it shows up early that there's a problem on the project, and the project managers don't always like that. They like to feel that they're in control and managing the situation.
So in an organization, the project controls manager reports to a project manager?
Sometimes they report to a project manager, sometimes they report direct to a project board, so that the project controls manager becomes the conscience, a bit of a policeman against the project manager, and that can raise conflict, of course, because nobody likes somebody looking over the shoulder and seeing what's going on. But it's a difficult area, so if the project controls manager thinks something's wrong, the project manager might try to block it or say, well, I'm going to sort it. Just some questions about successful projects. Can all remember the 2012 London Olympics? A few around the room, was it a successful project? It's a difficult one, isn't it? Generally, the press and the country thought it was very successful, and the quote on time and on budget, and there was a well-run programme of works. But if you go back to 2005 when the announcements were made, I can remember Tony Blair coming back from the Olympic Committee and announcing that it was a £2.4 billion project to bring the Olympics to London. The costs kept escalating, and when it got to 9.4, decided to do something about it. I mean, that's a lot of money, so the initial estimate was wildly wrong. Now, if Tony Blair had come back and said the Olympics are coming to London, if we're going to spend 9.4 billion on it, somebody might have had something to say about it. They might have tried to stop him. So the initial estimate doesn't always have to be accurate, and there's a theme to that run through this. Often people try to minimise the initial estimate so that the project gets sanctioned and goes ahead, knowing full well that it's going to cost more in the fullness of time. So it was delivered on time, obviously, because the Olympics all ran. They did remove some scope from the project, and they used a lot of target cost contracts. And for the first time in this country on a large-scale programme of works, they used project control techniques to try and manage it, so that they got identified where the problems were coming. They did that early. But as I say, if the 9.4 was known about in 2005, would the Olympics have gone ahead in London? Maybe it's not. Another example, the Channel Tunnel. Has anybody been on it? It's a pretty impressive piece of engineering. Those that have been on it, I think you'd agree. It's set a lot of world records. But the initial estimate was 2.6 billion, and the outturn cost was of the order of 4.6 billion, so almost twice as much, 80% out. So commercially it was a fail. They can't repay the loans that were taken out to fund the construction, and the ferry companies haven't been put out of business by it, which really they should have been by now. So brilliant bit of technical engineering, so the engineers in the room will be quite proud of it. Commercially, not very good. And my particular favourite, the new Wembley Stadium. Remember, they demolished the old one and built a new one, and this was organised by the Football Association. And the bit I draw your attention to is the build costs, the £352 million to build Wembley Stadium. So the Football Association had their monies ready, and they awarded a fixed price contract to a company called Multiserve. Lots of changes occurred, there's lots of disputes, and the price moved up to 458. and that was accepted by all the parties. They said, well, we've asked for all these extra things, we've changed what we wanted, we've moved the design. Some bits in the original design didn't work, it didn't satisfy the safety for the spectators and things like that. So the price moved up anyway. Already the Football Association's in a bit of a state because it expected, and it only financed 352. Then the dispute started, and the lawyers got involved. It didn't go to court, it was going to court, and already spent millions on lawyers, so they decided this is silly. They got the senior guys together and they decided that the Football Association would pay the contractor 70 million, and part of the agreement was that they then would pay back 35 million. I'm not sure why that happened, but there'll be some reason for it. But it was widely reckoned that the contractor lost 148 million even after he'd settled. So the question in terms of estimating, if you wanted to build another Wembley Stadium, could you use this data to advise how much it's likely to cost? And if you do, which figure would you take? Would you take the 352, which is what they thought it would cost, the 493, or the actual cost to the contractor of 641? So you can see, if you're looking at existing projects and you look at how much they were at the start of the project, midpoint or at the end, there's a lot of different figures there. And what you find happens when people try to do estimates, look at previous projects and look at them at the tender time, at the time that the contract's awarded. So in the case of Wembley Stadium, for the build, they look at that figure. So again, not a good outcome for the Football Association. So the government's very aware of this, and the Office of Government Commerce looked at a broad range of projects. So this is covering things like Ministry of Defence type requisition programmes, building new ships and tanks, aeroplanes, IT projects and construction projects in the public and private sector. So building new oil refineries, power stations, bridges, roads, rail links. And the outcome was quite shocking, really. 56% of the projects are delivered late. And I'm currently working on a project in the defence sector. It's submarines. I can't tell you who the client is, but you can probably guess. And the submarine's being delivered, and it's 400 weeks late. That's almost 10 years. So why did that happen? Well, it's a series of things, and nobody really had control over it. 50% of projects exceed the budget, so it's a 1 in 2 chance of overspending. 32% of projects have defects that impact on the end user. They tend not to make the press, but there's the Ministry of Defence, the Type 23 destroyers. They don't make enough electricity on board to run all the systems that they've got. They're going to have to repair them all. Massive cost to the taxpayer. Often see roads. The A1 Western Bypass was just opened, and then there was a sinkhole opened up, and there's a big dispute about whose responsibility it was to look for those before they built the road over it. So there's a lot of defects in projects, but you tend not to hear about them unless you're involved in the project. And almost a quarter of projects left the client organisation dissatisfied with the whole process. One of the problems, especially in construction, is that all construction projects are prototypes. It's very rare you get repeat business. McDonald's have tried to do that with their takeaways, and Tesco's tried to do it with the supermarket and a standard type of building. But that's the exception. Most of them are prototypes. And in a lot of organisations, a major capital project is a once in a career opportunity to get it wrong. So a lot of people, high flyers, go into projects, they think they're clever people, and because they haven't understood the basics and understood that they're dealing with a unique situation, they come unstuck, and it can impact on their careers. So what's happened about it? Well, the government's aware of this, and when I started researching, I was going to tell you, I looked at the Latham report in 1994, the Egan report, but there were earlier reports going back to 1934. There was a government report called Reaching for the Skies, which looked at how we procure. That was basically around public procurement. But they said that projects aren't delivered on time, they go over budget, and have defects when they're delivered. So in all those years, nothing's really changed. Fairly recent projects I've looked at, Wembley Stadium, the Olympics. The power station I'm working on, is that going to finish on time and on budget? We'll find out in 10 years' time when it's due to finish in 10 years, so we'll see what happens. So what's the government done about it? Well, it introduced legislation. The first bit was the Housing Grants, Construction and Regeneration Act, and that was about increased clarity of payment, because one of the big problems you get in a contractor and client relationship is when the project's not going very well, the contractor doesn't get paid. So they try to make payment terms fairer, because if you're a constructor, an engineering company or a building company, and you've done some work and you're not getting paid for it, it causes problems which need to be addressed and end up in dispute. And it improved the rights for contractors to suspend their work for non-payment, and it made the adjudication more accessible. Do you all know what adjudication is? Dispute resolution. Because what tended to happen is that a construction project would be finished, contractor looks at the accounts, says I've lost money, so they start raising disputes and the lawyers got involved. So what they're trying to do is say deal with the disputes as you go along, rather than save them up to the end. So is that a new problem, or is it just in the UK? Well, that's the oldest reference I can find to bad estimating, which is from the Gospel of St Luke, about if you're going to build it out. If there's any Muslims here, I'm sure there's something in the Quran as well, but I haven't read it. So it's not a new problem, that's 2,000 year old. And we don't consider, or we're too enthusiastic as we launch into a project about how much it's going to cost, how productive people are going to be, where the materials are coming from, and we do get mocked still. So it's not a new problem. So to improve the likelihood of success, most successful organisations that run lots of capital projects have introduced written procedures and written requirements to control their projects, and they have auditors to make sure that people comply with the written procedures, and often they have reporting requirements to senior management, so you have people remote from the project, so not people that are involved in its actual delivery, that take an overview of how progress has been made and try to take a sensible view of things. And sometimes that's board level directors, but it can be a panel of stakeholders. You might have the bankers in there just looking to see that you are doing what you said you would do when you said you would do it. And introduce a gate process to stop runaway projects that, because the people that are working on it want the project to be a success, they sometimes exaggerate or even tell lies about how things are progressing to make sure the project goes on. And I've been involved with that myself. I was working on a rail project. The metro, when it got extended to Sunderland, it was a project. It was £95 million at the time, a few years ago. And I was the commercial manager on that, and I got involved. Contracts were already awarded, and I started topping up the contracts and how much money it was likely to cost, what the risks were. And I was coming to 150 million. And I made a career-changing mistake. I told the project director from Railtrack at the time I was going to cost more than 150 million, and he didn't want to know. He had me removed from the project. I had somebody came and says, oh yeah, we can do it for 95 million. It eventually cost 155 million. So why did he have me removed? Well, he could go and tell the government who were funding it that, yeah, we can do this for 90, and everybody signed up to it. Then he breaks the bad news to them slowly. But it's all taxpayers' money, so I thought I'd done the right thing. That's a typical gated process. I'll put my glasses on to see that. So at concept stage, you progress the project looking at options, the estimate, the schedule, supply chain appointments and engineering. But you only progress it up to a certain stage, and then you go for approval to progress to the next stage. And the idea is that the client's organisation will release money for the various people involved to progress it to that stage. So obviously in the early stage of a project, a nuclear power station, they might release £1 million to do a concept design, like where could we place it, will we get planning permission, what kind of design could we have. And then as you move through the various phases of the process, the programme and the estimate become more and more accurate, and people are constantly reporting back, and you have this overview of what's going on. That makes sense to everybody, the gated process. In terms of how you're spending money, so the red line's money you've spent, and the green line's potential for savings. So in the early stages, if you don't progress a project, obviously you can save all the money. But as you go through the stages, you've got more and more sunk costs. So on the project before last that I was working on, it was an energy from waste plant down on Teesside. An American company ran it, and it sunk 750 million into this project, and as they tried to commission it, the thing wouldn't start. So eventually they made the decision to abandon it. So they've got 750 million of sunk costs on Teesside of pumps and turbines and incinerators, pipelines, pipe bridges, and just sat there, brand new, hardly used, and of no value to anybody other than the scrap. So that was a runaway project, and the problem was it should never have got past feasibility because the technology didn't work. It was basically a blast furnace, and you put domestic refuge into a blast furnace, fired in oxygen and burnt it, and drove off gases which they used to burn to raise steam and turn a turbine. So it sounds fairly simple. They couldn't get the technology to work. But they built one plant and now was 3/4 of the way through the second plant. They didn't do the estimates very well either. It was all very badly run. But it was a new and exciting area for this company. They usually extract, mainly manufacture pure gases, so oxygen, nitrogen, helium, etc. That was their background. This was a new exciting venture, so it could make lots of money if it worked, be about 90% efficient in terms of heat reclamation, and everybody got carried away with it, and they didn't follow their own internal normal processes because it was a different plant, much bigger in scale than anything else they'd ever built. And so how it came to an end is a Texan came over in his private jet, landed at Teesside Airport, got into a big hire car and came down, had a look round, said, right, stop, and you're fired, you're fired, you're fired. And these were senior people in the company that had authorised the project. So I mention this, and there is a serious point to it, because you're engineers, you'll be involved in projects, and some of you may have ended up being project managers. Watch out for the runaway projects. Somebody once told me, to be a good project manager, you need to be on the good projects. And I said, well, how do you sort the good projects? He said, well, they're the ones that don't go wrong.
I have one question. In this example which you told, the client didn't check about the previous history of these technology providers. The
client he built in a university in America. They built a mock-up, and it's just a blast furnace. It's not new technology really. It's just a different use of existing technology. But the thing, we were working next door to the plant that they were commissioning, and they had 2 or 3 explosions that burned through the blast furnace in 2 weeks, went through the walls, through the refractory. The pipe work was corroding at an excessive rate where they were drawing the gases off. We just couldn't get it to work. Now, if they pushed on, they might have got it fixed. But all the big boss saw was money going into a bottomless pit. So he stopped them all. And they sat there. They're just down on Teesside there. You can go and have a look at them. There's a brand new gatehouse there, unused. That's what's the value of that? Nothing really. It just needs to be demolished. And of course, there was consequences of that because it signed up to a lot of waste contracts for people to supply domestic waste of a certain specification. I didn't know you could specify domestic waste, but apparently you can. So that they dropped out of those contracts as well. So why are they so often got wrong in terms of estimate? Well, it can be difficult to forecast the future. Some things come along like the impact of Brexit. I'm working on the nuclear power station down at Hinkley Point. The the pound dipped in value, and a lot of the goods on that project are coming in from mainland Europe and further afield. So that makes them relatively more expensive if you price everything in pounds. But it's the French and Chinese companies that are funding it, so I don't know how they've probably priced it in euros. Again, that's not to their advantage. Too often insufficient effort's put into the early stages of an estimate. People tend to guess, or they're too optimistic, or they think they can get it cheaper than anybody else. Initial estimates are carried out based on too many assumptions. Data on which the base estimate is often limited. I've already been through the examples, the 3 examples there. Which data do you use? And data is not always readily available. A lot of private companies don't release their information. Public sector organisations have to release that information, including people like the utility companies. So there are examples of pipeline data that's available from the likes of Northern Gas Networks, but they don't like releasing it, so they don't often tell you the full story. Estimates are often unstructured and sometimes little more than a guess. They should be based on a work breakdown structure with all the various components listed out, detail exactly what the estimate includes, probably more important what it doesn't include, and where the data is coming from. I've already said about estimates being deliberately got wrong, and it's easy to randomly reduce the amount of an estimate. I've come across that many times where you'll get a chief executive who'll see an estimate, and it's a £3 million estimate, and you say we can do that for 2.5, take it out. It's easy to do that. It's very difficult to deliver £3 million worth of work for £2.5 million, and that happens very, very regularly. You're all being very polite. You're all all right? Still awake? So where you need to be vigilant, particularly where estimates are based on limited data, or one previous project, or even no previous projects. One of the schemes I'm working on, you might have heard of ITER, the nuclear fusion plant in the south of France. Well, they've got estimates for something that they've never built before. They haven't actually got a completed design, but they've got estimates ready. Now, how they're doing that? They can, by definition, be little more than a guess. You don't know what you're doing or when you're doing it. How can you know how much it's going to cost? And the way that works is governments keep putting money in and they do a bit more work, and then it sort of slows down again. It's an interesting project. There's no attempt to break a comparative estimate down to components within a previous comparable project. So if you just look at like the Sunderland Metro, where I said it was 95 million, I didn't do the estimate like that. I broke it down into, well, the line work's going to be this, the work to the existing lines, that, signalling, electricity supplies, stations and platforms, they're just buildings. So I broke it all down so that you could see where money was missing. And straight away, for instance, I could see that the supply of electricity to run the trains, that nobody had priced for it. The links back to the national grid, that wasn't going to just pay for itself. It had been missed out of the original estimate. But as I say, the organisation that I was working for didn't want to know that. The spread of cost is missing. Like most estimates, especially in the early stages, you should be saying plus or minus 50%. One of the problems there is the first figure that people hear is the one that they remember. So Tony Blair saying 2.4 billion for the London Olympics, that's the figure I remember, not the 9.4. Updating of historic costs or forecasting inflation into the future is fraught with difficulty. We keep getting caught. Governments can't forecast how much inflation is going to be, how much things are going to go up in prices. So how can we be expected to do that? Be particularly careful where there's multiple currencies being used. I've already highlighted, the Hinkley Point C, where they're paying for things in euros and dollars and other currencies. What's the Chinese currency? I can't remember. Some stuff's coming from China anyway, so and the exchange rate varies. Is it the yuan? Is it or? Yeah, I couldn't remember. need a comprehensive list of inclusions and exclusions, so that there's no disputes as to whether things were included in the estimate. Need a structured risk analysis. I think there's another module you do on risk analysis, isn't there? So I'll stay away from that. It's a huge area in itself. A programme or a schedule of works isn't referenced or identified. And especially where the project's not designed or scoped, if you don't know what you're doing, how the hell can you put an estimate on it? Well, people will insist that they can do it. So, sources of data. A lot of clients have their own data and they analyse their own projects. Published data, price books, there's a number about Page and Nation, Laxton's, Spons. A lot of consultants, my organisation spends a lot of time analysing projects and putting them into big databases, and they're very, very protective of them. They don't want to share that data with anybody else because we spent time and money doing it. It becomes our intellectual property, and other consultants do the same. Contractors and suppliers, of course, have their own databases, because if you're going to tender for something, you need to know how much it costs to, prepare and fab a 6-inch pipe, for instance. You need that information. Some learned institutions, the Association of Cost Engineers, try to collect and save data. And there are software systems. One's called Icarus, where basically you tell, that's for in the chemical industry and the oil industry, you tell it what the main plant items are and the capacity is output, and it goes away and works on algorithms. I won't pretend I understand it because I don't, but it churns away and it gives you a fairly accurate initial estimate, and then you can refine it. And it prompts as well the right questions about sort of locations and currencies. It prompts all the right questions to be asked. But the data used must be understood. If you just get somebody tells you, if you use this price, understand why he's telling you that, and understand the inclusions and exclusions. Collecting data from live jobs is very, very costly. The Water Research Council and Ofwat have what they call TR61, which is a cost database, which they populate. It costs an awful lot of money to do that.
Excuse me, in the slide, what does NB means?
Sorry?
What does NB means?
NB note.
Oh,
Sorry.
okay.
Yeah. I'll take that out next time. Just note the following.
Yeah.
And which data should be considered? Is it the tender prices, the output cost, the final cost, the cost of the contractor, how much people pay for things? Very difficult. Just in terms of pipelines, if you consider, if they were all, and I know they're not, 6-inch diameter pipes, what would the costs be like? For the one just sort of going across the wilderness compared to one going over a pipe bridge compared to one on a chemical plant. They'll all be significantly different, and they've all got different inputs. So you do get people say, well, 6-inch pipes costs this, 9, 12, 15, 30-inch. Very difficult. You've got to understand where their data's come from and what the data is that you're looking at. So what's the purpose? The initial purpose of the estimates is to provide information on which future investment decisions are made. So it's not just the cost of the project, it's the cost of the business. So in the Channel Tunnel, they had to do an estimate to see how much the Channel Tunnel would cost, to see if the business case stacks up, so that they know if they're going to get how many customers they need to get, what they've got to charge them to go through the Channel Tunnel. All that work that they did early on, they had to bin that because it didn't work. They couldn't charge people the proportion comparative to the cost of the tunnel, because nobody would have gone it. They've all used the ferries, so the basic business case didn't stack up. It's to provide information in a structured way that can later be used to control costs, so it's not just a lump of money. To plan the cost and cash flow requires integration of the schedule and packaging work. We'll come on to this. This is part of the start of earned value analysis, but if you know how much individual components are going to cost, you need to be able to compare that with the programme so that you can work out what the cash flow is going to be. And it's amazing how many organisations don't do that. And then the big reminder, remember the first figure people hear when you tell somebody that's going to cost you £1 million, and they don't hear the plus or minus 50%. You just hear £1 million, and that's what they'll hold you to account for. So you need to be very careful. There's various classes of estimate, and the class that you can do is often constrained by how much money the client's got to invest in preparing an estimate. But the initial capacity or a factorial estimate, plus or minus 50%, that's a class 5. Class 4 equipment factor estimate, so you're looking in terms of oil and gas. If it's an oil refinery, you look at all the different plant items that you've got and get prices for them, and try and factor in how much the support services will cost. Semi-detailed estimates, so you're starting to look at the quantities of the major items. A detailed estimate, where you're looking at, you're taking the quantities off and trying to price up the quantities of materials and labour through to a full detailed estimate. And the level you go into depends on the client organisation and that procedure that they've written. And hopefully, as you go through the various stages and through the gated process, the estimate becomes more and more accurate. Not always the case, but it should do. And it needs to be done, as I've said before, against a work breakdown structure. It must be reduced so that you know which components are being priced, the price of the component within an estimate, and the work breakdown structure needs to be mandated and controlled, because what you'll find is the planners will have their own work breakdown structure, the estimator will have his, the engineers will use a different one, and you end up with bedlam. You saw that I was involved in looking at a project to see the risks involved in it. It was the underground system in Amsterdam, and basically what they've done there is they've broken the underground down into different components, so they have 100 kilometres of shaft with all the ballast, lining, signalling, the electrification rails all in place, and had a price for that. What the planners had done is they'd planned driving all the tunnel and then putting the ballast in, so you couldn't align the costs with the programme, and they were going to use earned value analysis to control that project, and of course it just wouldn't work. So you need to use the same work breakdown structure in the schedule and the plans, and it's got to be used to establish the baseline estimate. So some of the techniques in estimating unit costs, you can have a square metre of building. Certainly if you're doing a building like this one, there's a lot of information published by the RICS under the Building Cost Information Service, that's the BCIS, on per square metre of floor area, and it gives you a very good initial estimate. Then you need to be looking at the exceptions, if there's anything strange about the building. Northern Gas Networks have estimates for a kilometre of pipeline, and they've got their own databases and they understand them, and because the specification's always the same, it makes them quite accurate. It won't be the same if you're working on pipelines, because you'll be specifying different grades of steel for different locations. Direct comparison with other projects can be used, but it's often very risky to do that. I've already said Wembley Stadium. Man-hour and resource take-off, factorial estimates in the chemical industry, where I've worked a lot of the time. If you take the main plant items and you can get the costs for them from suppliers, if you multiply that by 4.3, it gives you a very good early estimate. And as a colleague of mine, when I pointed that out, he said he works in pharmaceuticals and he does the same. He takes the main plant items, but he multiplies by 9.6. And that works in pharmaceuticals, but you've got to have understanding of the trades to be able to do that. Approximate takeoffs, and that's what I prefer. If you get the quantities, start looking at how much labour is going to be involved, what the materials are likely to cost, it's going to be more accurate. Then most estimates are a combination of all of those techniques. So if you have buildings, you might be able to do it off a square metre, but the stuff in between, you'll use a different approach. Already done that one. Some difficult areas in estimates, understand the scope of the estimates, what's included and what's not included, because often in the early stages clients will be very vague about what they want. Producing an estimate with inadequate information for new technology. My local authorities just painted yellow lines everywhere along the seafront and put some car parking spaces in and put some meters in so you can put some money in. And they've opened them at Easter and they've now closed them because it doesn't take the new pound coin. Somebody didn't think about that. Now it's fairly obvious, isn't it? But if I'd done that I'd probably get sacked, but there we go. Be aware of basically politics, office politics, company politics and client politics. That often affects an estimate, especially with very senior managers. You know, you'll spend a couple of months preparing an estimate and the very senior manager will say, oh, we can do it for half of that, and that's what we'll go with. Very difficult. You really need to stand your ground, although I stood my ground and got removed from the project, so I'm not quite sure how you do that. Deal with costs in use. Often what we tend to do is to design things down to a price, which means that you get higher life cycle costs. So you know, it's you should be able to consider the various options over the life cycle of the project. There was a famous case in my company. We spent a lot of money doing life cycling costs on a road for the Highways England, and all the answers came back that what we need to do was put a thicker wearing course on so it lasted for 40 years, but we couldn't afford the capital costs. So they put a thinner wearing course on, the road will wear out, and then they won't be able to afford to maintain it, so you end up with potholes. It's great. So there is a right answer, but it wasn't affordable. An estimate of future operational costs, a very complex area. One of the estimates that I'm involved with at the minute is actually the cost of decommissioning the Hinkley Point C power station. We're actually looking at how they might go about doing that. Now, given the thing isn't built yet, it's not going to be built and commissioned for another 10 years. It's got a life of 70 years. The people that are commissioning it, you know, probably their parents haven't been born yet. So, a long time ahead. The reason I mention it is it was a decision made in the 1950s and 1960s in the nuclear industry and in oil and gas that are only now being addressed in terms of decommissioning. So we built things out of concrete, perhaps we should have built them out of steel and it would have been easier to decommission. And if any of you have had any involvement with Sellafield, have you seen that? The Sellafield over in Cumbria, where they deal with all the used nuclear waste. We just piling loads and loads of money into that because there's things that are too dangerous to handle. So you need to invent a machine that can encapsulate it to make it a little bit safer so you can take it away and then start decommissioning the plant. And the way the old nuclear system worked, the Magnox system, is you had canisters and you had to put them under water and take the top off and take the fuel out. And they did that at Sellafield. Well, these ponds have become full of sludge, so now they can't empty them. And one of the pond walls is cracked, so the medium level nuclear waste leaking into the groundwater. Tremendous situation. But it was all about decisions made by people that's probably no longer here. And it's often neglected, but it shouldn't be. Especially as most of you are going to work in oil and gas and need to be aware of the future costs. And in fact, there's legislation about that now. So some of the other difficult areas, dealing with escalation. How do you update costs? So if you've got a project that's perhaps 5-year-old and you've got some data you want to use from there, how do you update it? Well, you can do it with statistics, but how do you know which statistics to use? Dealing with foreign currency is also a problem, and if you have foreign currency, it's important that you state very near the front of the estimate report what exchange rates you've used and what view you've taken of the future changes to the exchange rates. Always state the currency and not the country where the work's being executed. There's a lot of work I do that's priced in US dollars. So it might be an English design company building work in Nigeria, but it's priced in US dollars. Oil industry prefers dollars. Just in terms of of dealing with difficult areas. There's some information over 6 years. Some indices from the Royal Institution of Chartered Surveyors. So I've got a number there. Average weekly earnings. But the top one, tender price index. If earnings are only going up at this rate, why are tender prices going up at a higher rate? Anybody got a view on that? Because it should be a factor of, you know, the base costs to the contractors aren't going up. So why do tender prices go up? The answer is it's the market conditions. They can get away with charging more for their jobs. So you can get the silly situation where if prices go down, tender prices might go up. So the two aren't necessarily mutually inclusive. So you can see there's a fairly standard trend there of how prices are going up, but the prices that were put in for tenders go up considerably above that. And there was a period, if you projected this back, where prices were going up, but tender prices came down. There's a shortage of work, and contractors were cutting the costs to try and keep their resources deployed. So it's not straightforward. So don't think because you take the retail price index or the average weekly earnings or even if you take the average weekly earnings in construction, you can see they don't move in the same pattern as the rest of the economy. So it's very difficult to forecast the future is all I'm trying to get across there. Looking at planning and scheduling. So planning, and by this I mean sometimes it's called integrated network analysis. That's how the various bits of the project hang together. It was established in the 1950s, and DuPont, who I used to work for actually, and the US defence sector established it. So looked at what you had to do to come up with a programme of when you would be doing it, so you could get the resources ready and make sure that the materials were delivered on time, and it was seen as a big step forward. So today, most planning involves either industry standard Primavera or Microsoft Project software. Any of you use them? Usually somebody used Microsoft Project. You use Primavera?
Primavera.
Yeah. Very powerful system, isn't it? Very big system. Adds to the confusion because people don't understand the outputs that they're getting. But is that fair?
Yeah.
An increased computer power has led to more complex programs being produced. So often that's become part of the problem. So rather than being used as a tool, it's used, well, Primavera says we've got to do that, and people just follow it. And then you find there's some problem with the program, which we'll come on to. Planning suffers similar problems from estimating. Time overruns on many projects being well documented. You know, the nuclear submarine that I mentioned, 400 weeks late. Shockingly bad, but they did use planning on that. And some of the newer forms of contract require programs to be established and agreed by the parties. NEC, New Engineering Contracts, one of them, actually demands that there's a program done and agreed. So, common problems to look for, and you'll know this if you've done Primavera: open-ended activities where there's no predecessor or successor, incorrect use of constraint dates, and push your program up where it's not where it needed. Negative lags, activities start before something else is finished. I've seen a program where they were fabricating the steel before it was manufactured, and it was just somebody had put it into it and didn't really understand what they were doing. Incorrect software settings, they're very difficult to spot it unless you're immersed in the planning process. And excessive detail. You know, the human brain can only deal with so much information. You start planning down to when certain nuts and bolts are going to be tightened, you just can't deal with it all. And over-reliance on computer outputs, not really understanding what the issues are. We all know what GIGO is. It's an Americanism. Garbage in, garbage out. Yeah. So if it's not proper data, you're going to get a bad answer. The problem is a lot of people don't realise when they've got a bad answer until it's too late. Project managers and other team members not using the programme but develop their own and that is a very, very common one. Because the Primavera and Microsoft project outputs are so complex, a lot of PMs will write their own program in, often in Excel, or on the back of a fag packet as we call it, and they'll try to work to that because they understand it and they don't understand the big program. So cost management, it's a process of planning and controlling budget that allows expenditure to be forecast to reduce the likelihood of overspending. And as you go through your career, you will have some software company who'll come to see you and say, we've got some cost control software, and if you buy this and apply it to your project, all your problems are solved. All that does is measure costs. It takes management, it takes people to control costs. What some of these systems do, though, is give you the information to warn you that there's a problem. Projects and contracts often don't deliver what's intended. Reasons for that are many and varied, but some of the causes, once in a career opportunity to get it wrong. You know, senior managers just saying we're going to do this, as happened with the waste management company down on Teesside. Too little applied at the effort applied at the early stages. Even in experienced organisations, processes are put in place but are not adhered to, and you quite often see that in government departments. You know, the NHS will introduce an IT project and it doesn't deliver, and when they look into it they say, well, they didn't even apply their own processes to this project, just somebody thought it was a good idea, and it's a bit too difficult to be compliant and go through the gated process, and somebody might stop you, so they push ahead regardless. And often parties are dealing with unfamiliar organisations, new third parties, different contractors, different design houses, unfamiliar working arrangements and contractual arrangements. Teams brought together for one event and then disbanded. So one of the things that they're trying to do on Hinkley Point, it's a 10-year project, is they're trying to build the teams together so that people stay there. Obviously not me, I'm not going to be working in 10 years' time, but you know, if some of you were to go into that project, they'll be trying to keep you there, and so you apply that, you teach you their processes, and then you apply them throughout the duration of the project and see if it works. So cost and schedule management brings together the cost and time element of a project to achieve the baseline. So that's a step. Plan the activities, baseline the activities so you know when you should be doing them, track against the baseline, analyse so that you know why things have changed, constantly reforecast, make any corrections and verify. Fairly simple process. So here's an example of baselining, and on the blackboard there's a bill of quantities for a pipeline at Cowton Hewley. So analysing the project, and I've just done that myself, it's one I worked on, and I've come up with this, which is really a fairly simple work breakdown structure for that project. Just one I've made up. You then look at the programme against the same work breakdown structure, so you can compare the costs with the time elements. And then put the costs against the programme simplistically. So that's when you should be spending the money, if it all goes to plan. That's the baseline. So what happened on this project was that the red line is how much money we'd actually spent. So I can ask a question. The blue line's what you said you were going to spend, and the red line's what you've actually spent. So is that a good project or a bad project?
Good.
Why is it good? Because you haven't spent your money.
That's on schedule.
Who thinks it's good? Who thinks it's bad?
It's a bad calculation.
Who thinks you haven't got enough information to make a judgment?
Yeah. Bad calculation.
Yeah. Because that was happening, and the client was happy because he wasn't spending his money. He also wasn't making any progress. And what had happened was, we found one of them. I don't know if you know Cowton Hewley. It's flat lands with a lot of water in it. the pipeline was going in. There's pipeline corridors along there, so there's already various chemicals and things being transported around that site, and this pipeline was just going alongside one of them. That's a great crested newt, and they're a protected species. So this project was going along, and one of the workers was walking along, and he saw one of these. So now some people say he should have just stood on it and ignored it, but he didn't. He did what he's supposed to do, and he flagged it up. So that effectively the programme stopped whilst they decided what they were going to do. And this is when I got involved, because it was quite interesting. I had to build a newt-proof fence. Have any of you seen one? It's a piece of polythene about that high, because they can't jump, to keep them away. And then you had to wait till the end of the breeding season, so then you had to get somebody who's licensed, and I'm not joking, to handle these newts, to go and pick them all up and take them to another pond where they'd be safe. It cost a fortune. The pipeline didn't get finished on time. The contractor had to be paid because he had all his plant and equipment there. When he started again, he was now building in the winter rather than in the summer, so he wanted higher costs. It's a classic example how not to do it. And the risk analysis for the project hadn't identified environmental issues as a risk, so unmitigated disaster. Now, some people don't believe that a creature that sort of about that big can cost so much, but there's lots of examples of construction schemes having to be put on hold because of this legislation. And to be fair, when I was a child, there was lots of these things about, and you don't see many now, so they are endangered.
Excuse me. How is it possible that in the environmental impact assessment these animals were not shown?
They hadn't done one properly because they were in a hurry because they wanted to get this pipeline built, and a pipeline was getting taken out for a motorway alteration, so they wanted to get another one in to move the gas. It should have been, but it wasn't. It's like a lot of things. If we'd only done that, it wouldn't have happened. But it should have been in the environmental impact assessment, but it was done crudely at best. But to be fair to them, it was following the route of other pipelines. So you're working in an environment where there's already pipelines there, so it wasn't across virgin fields or anything. So that was probably taken into consideration, and they weren't expecting to see these.
Maybe the other
but they were there.
were not properly.
Yeah, I mean, where I'm working now, they've had to put in a badger hotel because badgers are protected. So they moved the badgers from where they need and put them in this badger hotel, and they've moved out. They don't like it. But 20 miles down the road in Somerset, they're shooting badgers because they're spreading TB. It doesn't make sense, but what do I tell you?
Let's go one killed.
There's lots of, if you hit one in your car, it's quite dangerous because they're quite a big animal, so it can do some damage. But yeah, so 20 miles down the road from the power station, they're shooting badgers, but where they're building the power station, you've got to handle them carefully. And the danger is that they tunnel into the embankment and flood fields. So if you plot the actual expenditure, the red line, what's that show? Doesn't show anything, so you need to use something called earned value analysis. So a bit of background on earned value analysis, and pay particular attention here, might be a hint there. The government has commissioned my company to look at earned value analysis on the nuclear submarine projects going forward, so that if there's a problem, they find out early enough so they can do something about it, rather than have a submarine that's 400 weeks late. You about that 10 years ago, you might have changed what you're going to do to try and address the issues. So earned value analysis, a bit of background, was developed in the USA, as a lot of these things are, on government programs in the 1960s. And in the 1980s and 1990s was being used by project managers. Project managers do study this, and not just by specialists. A lot of project managers don't like this though. I've got to say that in my experience. And in 1991 there was the famous case of the US Navy. They had the Avenger stealth project. It was a fighter bomber they were developing to launch from their aircraft carriers, and it was cancelled because of the problems identified by earned value analysis. So successful, but they'd already sunk $1 billion into the programme before they decided to cancel it. And then of course, because it's America, there's lots of lawyers and people suing each other for cancelling the project, saying, well, we would have been on time and on budget. And these fighter bombers, the stealth bombers, they cost more than their weight in gold, so they're not cheap. So the US Navy don't have a stealth fighter bomber as a result of earned value analysis. Increasingly in engineering projects, EVA is being used as a tool to monitor and identify issues to allow time to take corrective action. So its requirements needs a baseline, which I've already explained, a very simple baseline, and hence the need for a work breakdown structure. It requires that progress is monitored and the actual cost of the work breakdown structure components is reported and compared to the estimate to give a cost performance indicator. And by comparison, what has been achieved and completed and what's being planned to be done in that period provides a performance indicator. So what is it? It's an approach for determining and measuring of work and predicting project results. It's a tool that if used properly, and only if it's used properly, and there's lots of reasons why it's not, it can give early warnings of problems, but it's only a tool. The fact that you get a bad result from earned value analysis doesn't necessarily mean you've got a problem, and the fact that you don't get a bad result doesn't mean that you haven't got a problem. It's only a tool, one of many. You might use another one, for instance, milestones being achieved. Value is determined at the start and it's earned as work progresses, and if progress is to plan, then earned value is actually the same. So why do we use it? Well, it gives a transparent set of metrics. So it's basically saying, are you doing what you said you would do and spending on it what you said you would spend when you said you would do it? And if not, it flags it up. It allows comparison between different types of work, so you can compare IT projects with engineering projects, with defence projects, so it works across a range of activities. It's scalable to a programme or a portfolio of work, and it's an approach for determining and measuring progress of work and predicting project results just by comparing planned with actual. If the two don't balance, it might be that the programme as planned was wrong, or the estimate was wrong. But at least it flags up early in the process, so you can use it. It gives a early warning of problems to the project or programme, and it gives it in such a manner that you've perhaps got a bit more time to do something about it. And it helps PMs and others ask the right questions at the right times. So where's it used? So it's common in industry, introducing it in defence. Oil and gas use it regularly, nuclear use it all the time, and it's becoming more popular. And in the US it's mandated on all government defence projects, and it's starting to be used on the UK by the MOD. The problem is who does it, because the way projects are procured, it's often the contractor, the supplier, that's going to provide the earned value analysis. Really you need a degree of independence there to see that it's going to happen properly, in my opinion, but since we provide that as a service, you might think, well, I'm going to say that anyway if you're cynical. So you establish a baseline, the budgeted cost of work scheduled, you measure the actual cost of work performed, and then you've got the progress, the earned value of the budgeted cost of work performed. So by comparing them, you can see there's lots of acronyms in here, we'll spin through that. So you get to the schedule variance. If you take the budgeted cost of work performed and compare that to the budgeted cost of work scheduled, you can see if you're ahead or behind schedule. And in terms of cost, if you take the budgeted cost of work performed and the actual cost of work performed, you can see if you're under or behind on budget. So there's some worked examples. Probably best looking through them yourselves. But the schedule variance is there. So you can see that one's behind. Are you doing what you said you would do when you said you would do it? And the cost variance, progress equals actual. So that's positive, so it's under budget. So it needs to be robust and appropriately detailed for the whole project. It's easy for some jobs and harder for others. Any plan can only be based on the best available data at the time of its creation though. So if you've got assumptions in there, it's going to affect your outputs in terms of the project. All plans change. Never forget that. I've never known a construction project yet that hasn't had any change in it, and you need to control the change. And you need honest and accurate updates each month of percentage or whatever complete for each task. So issues in use, why does it go wrong? It's a way to control projects including time and material projects, portfolios including front-end design. It's not a cure-all, won't fix everything. Not all project managers like it or work to it or accept it. Measuring and reporting progress needs discipline. And one of the big problems is you rely on contractors to feed back how much progress they've made. And they'll come back saying, oh yeah, you're 50% there, we're 90% there. If you accurately measure it, they're not 50%, they're only 45.3% there. And it has a big impact on earned value analysis. So if you're going to do it, you need to put proper resources in place. Measuring and reporting progress needs discipline. Some people don't tell the truth. They'll overclaim based on the fact they're going to catch up next month and then they go bust. If you're in my job and you've let that happen, you're in big trouble. There's going to be a claim on your professional indemnity insurance. Schedule time is measured in pounds, and that's counterintuitive. How to measure progress, for instance, free issue resource, quite difficult. Dealing with contingency, all projects have a contingency, but you need to release it, and there's a big argument about whether the contingency should be shown in the baseline or not. Preferably I'd take contingency out of the baseline, because you don't start a project thinking that you're going to be spending a contingency. It should all go back if everything goes to plan. Dealing with risk is difficult. Primavera, logic links, missing logic. You really do need somebody that understands Primavera. You're nodding. It is very difficult, and there's an awful lot of information in there. Alignment of estimate and the cost loading of the schedule is critical. Getting schedules from contractors. I've a law in the NEC 3 contract. There's a requirement that contractor provide a schedule and work to it. Some contractors refuse to do that. So why would they do that? Well, they don't want you to have something to control them against. Change control is another area, and changes in scope. Be aware of scope removed from the budget. If you look at, there's a tram system put in Edinburgh, and it was apparently brought in on time and on budget, but what you'll find is they didn't deliver the full scope of the project. It was significantly reduced to meet what was available. So, reasons it fails, and it does often fail: no documented requirements. I've mentioned that in estimating, I've mentioned it in scheduling. It's a problem. Incomplete requirements, work breakdown structure not accepted, or it's incomplete. Plans not integrated with the budget. Schedule and budget are incorrect. Might be an incorrect assumptions in the schedule or incorrect estimate. Change management not used, or it's ineffective. Cost control system inadequate. A lot of organisations rely on, for costs, they rely on the costs coming in terms of invoices, coming into their finance department, but there's a time lag in that. You need to be using absolute cut-off dates and how much cost is being incurred at that cut-off date, which might mean most contractors do a monthly valuation, but the valuation might be in the middle of the month. You need to cut off at the end of the month, so you need to run accruals, which are a whole issue in themselves. Incorrect progress. And management influence and or control. It's either missing or it's misdirected, or they're not interested. So change management, it's an inevitable part of any project. The likelihood of change needs to be considered and established in the contract. If you're going to go for a fixed price contract, as in the Wembley Stadium example, you really need to be avoiding change of any great extent and a failed. So it made the contract failed. It was something that went to the root of the contract, that failure. Contract terms and conditions will describe the procedures and entitlements for the contracting parties. Quite difficult, and it become a motive, and a lot of legal disputes are all around change and what the entitlement is. You know, especially if you find great crested newts, so you're now building something in the middle of the winter rather than in the summer. Contractors say, well, my rates don't apply, I need to recover it on the base cost to me. And bearing in mind that in that case they probably underbid the job, they'd be looking for a way out of their rates. All change needs to be managed to minimise the impact on the cost and time. So examples: changing methods or sequence of working, changing materials or specifications, dealing with emergent risks, great crested newts that should have been on the environmental risk assessment or badges. I've had jobs that are delayed because we found dead bodies, antiquities, things like that. The dead body was interesting because that was on the headland of Hartlepool, and we found a skeleton. And it turned out it was somebody that had been killed in a Viking raid. But of course the police are involved until they know that, so everything just stops. Expending contingencies and dealing with unexpected events. So the approach to managing change depends on the kind of contract. Some contracts, like NEC3, focus on change and potential change, so that both parties have to work together at an early stage in the contract to address the impact. And for contractual arrangements, the approach will be dictated by the contractual terms, and failure to adhere can give rise to claims. Quickly looking at risk management, we won't go into this in too much detail because you do it elsewhere, but basically identify the risks, classify them, quantify them, grade, and you're always seeking to minimise, and then the mitigation or transfer, avoid or manage, and that's an iterative cycle that you go through. By detailing all the known risks and estimating the impact on the project and the likelihood of the event occurring, then software. Did you get to use Monte Carlo? It basically runs different models so that you can it comes up with an allowance. Most projects go on the P50 allowance, but in nuclear they use P80. So there's the contingency within the project and the contingency that the client holds. So risk management is an emotive area, and senior management don't like it because it is uncertain. And if you remember the flooding that occurred at York, the Environment Agency had done some risk models, and the newspapers thought they'd found a real story when they says, oh well, the Environment Agency knew there was a risk of the pumps breaking down at York and not being able to control the risks. So they thought it was a big story, but in fact that's the nature of risk management, and a lot of organisations won't release their risk schedules based on that. So define what is and not included in the contingency and agreed and state that in the estimate and the cost report. Estimating accuracy is a separate issue and has to be addressed separately. Risk with a high probability, so if something's 100% likely to happen, then it's not a risk, it's a certainty, and you deal with it differently. You don't have a contingency. Contingency must reflect the level of confidence in the estimate and the cost report. Risks not identified against an unknown scope of works. As I said at the outset, if you don't know what you're doing, you can't control the risk. Risk and associate contingency will be managed throughout the estimate and throughout the project life. Reduction of risks invariably incurs costs. The client ultimately bears all the risk. He might take out an insurance policy, for instance, against fire or theft, but he ultimately bears the risk of the insurance policy. So you might try and pass it to the contractor or insure it and pass the costs back. Contingencies not to cover design or engineer errors unless that's identified as a risk, and understand who owns and pays for it. So typical risks that pass to the contractors, weather, site access, some changes. Typical risks addressed by the style of contract, work scope, site conditions, productivity and changes. So the risks that are usually transferred: fire, flood, theft, and common risks, and it depends where these sit. Strikes, you try to get the contractor to be responsible if there's any strikes. Company failure, insolvency and funding, well, you try to manage that by, before you award a contract, you'll make sure you're contracting with somebody who's a company of substance. Technological, especially software, or my example of the car parking, changes the pound coins, you won't deal with it. Reputation, good and bad publicity. A lot of companies very, very sensitive about that. You've all seen United Airlines. They didn't have that on their risk schedule about our security guards are going to drag somebody off and break 2 of his teeth and get us a real bad press. Legislation and taxation. Governments have a nasty habit of changing that and not telling people. Other projects might impact on yours. You mightn't be able to get labour and resources. And security. Security is a strange one. We used to always just have the odd guy on the site, but these days there's a lot more effort paid to security, especially on things like pipelines, where you'll get environmental protesters and others come to have a look. And anybody worked on any fracking projects? I was talking to a guy who works in fracking. If they're going to put an exploratory well down in Iran, which is near where ISIS are, the security for that typically costs them $200,000. If they want to sink a fracking well in Lancaster, how much do you think that costs for security? $2 million because of the environmental process. So it makes it a lot more risky. So really achieving what they want to do by just being protesters. You don't need to do anything else.
Yeah, so the company appoints a risk analyst of the project manager to find out the risk.
Depends on the project. Sometimes it's a specialist risk manager. Sometimes it's a specialist risk company. Some project managers think they can do it themselves, working with the project teams. You know, they get the designers, the engineers, the financial people in from the clients and the contractors, and we'll run through it and then say what's the likely impact. It tends to be a bit amateurish because they've come at it. Some project managers think they can do everything, and they fail. So it's about selecting the proper project delivery strategy. So if you set the project objectives and constraints in terms of time, money, technologies, selecting the proper delivery method, select the proper contract form and type, come on to that, and contract administration practices and methods. And bear in mind that costs money, the client has to pay for that. So contract strategies consider many issues, including the need to manage risk and transfer risk by the style of contract, how well defined the scope and design are, size and ability of the project organisation to manage the contract. Lots of organisations are quite small and need a project. They probably need to keep it fairly simple and get somebody to deliver a package for them, which means they need to complete the design up front. Requirement of the funders, so if you're going to borrow money from the banks, a lot of them will want an input into the kind of contracts you're using and understand how you're going to manage it, how you're going to guarantee delivery. Existing relationships, there might be a history of dealing with various parties. Sort of in this country, the MOD deals with BAE systems to build aeroplanes, tanks, ships, submarines. It's an existing relationship. I'm not saying it's a good one, but where else would they go to? Market conditions, big one, and we saw what happens to tender prices. They don't move in the same way as other prices do. Specialist input requirements, might be limited companies that can deal with things, limited companies that you're allowed to deal with because of regulatory controls. Resources and or organisations able to meet the needs of the contract and terms and conditions required. So come to contract style, and basically there's only 2 contract styles. There's lump sum and there's reimbursable, and all others are intermediates or hybrids between the two. traditionally we design and then construct, but you can get into direct labour, turnkey, build, operate, transfer. And this is the slide I want to get to. This is trying to give an oversight of which style of contract you need to be going towards based on the characteristics required and where you are in terms of the level of definition. So if you know what you're going to build, if you've designed Wembley Stadium and you know what the arches and you know where all the underground services are and you want to transfer all that risk to a contractor, then you can go for a lump sum contract, which is what they tried to do, but they hadn't got all the design right. And at the other extreme you've got a purely reimbursable, so you pay them for the resources that they use, usually plus a fee. And the others, sort of itemised lump sum, bills of quantities, approximate bill of quantities, they're all hybrids or intermediates between there. And you can see the characteristics at the bottom. If uncertainties are high, then you need to be more towards a reimbursable style contract, just so that it's equitable, that the contractor's not pricing in a lot of risk that you're going to have to pay for. Early start required. It's easier if it's reimbursable, because you don't have to specify everything. And with reimbursable, you really do need a high amount of input in terms of controlling the contract, because you'll find the contract will book everybody on the job. Terms and conditions, either client's own industry standard, contractor standard terms. Be aware of the battle of the forms. In some smaller contracts, usually not in big ones, because you usually have a firm of lawyers involved, you can get involved in the battle of the forms. That's where one party says to the other party, I'll carry out this work and here's my terms and conditions, and the other party responds and says, yes, we'll carry out the work, but we're on my terms and conditions. And the legal view on that is the contractor that gets the last shot in before the work starts is the one that terms apply. Some contract terms, these are the common ones that you'll come across at the moment. You go and work in industry at the moment, these are the three main third-party terms that you'll come across. The NEC suite of contracts, and you might have heard of these. They've got their 6 styles of contract. There are others, about professional services and what have you, and measured term contracts that NEC have also got. So they look at priced with an activity schedule, so that's a lump sum. Priced with a bill of quantities, another kind of lump sum. Target cost, which is what the Olympics was done on and what the nuclear power station has been built on. So you agree a target that everybody works to, but you adjust the target for agreed changes. Target cost with bill of quantities, cost reimbursable, a management contract of cost plus fee. So the E and F are the more reimbursable style. ICHEM, the Institute of Chemical Engineers, instead of calling them letters, they've got colours. Red's the lump sum, burgundy is the target cost. Well, they didn't call it purple, I don't know, but green, cost reimbursable, and yellow's for the subcontractors. And FIDIC, some of you might have come across FIDIC, that's more the international form of contract. Red's for civil engineering, yellow's for electrical and mechanical, and orange is design and build and turnkey. So you can see they don't align across. FIDIC have gone more for the kind of service that's being delivered rather than the style of contract. And it tends to be a lump sum contract, FIDIC. It doesn't get into reimbursable. So the idea is you give all the risk to the contractor, generally in FIDIC. Production of contract forms and providing training and guidance on their use and implementation and administration. It's a big business. A lot of money's made. They're quite expensive to buy those documents. And dealing with the legal consequences, disputes, adjudication, mediation, arbitration, and litigation through the course is another major industry in itself. And a lot of foreign companies, you might have sort of a Malaysian company dealing with a Nigerian company, a lot of them submit to English law just to get the certainty, or American law. They tend to stay away from French because that's a little bit different, but it's a big sale for the UK. We get a lot of disputes in our courts, and they are seen as being fairly honest, which is a rarity apparently. So I've finished in record time. Any questions? Dropped a broad hint about what the exam question might be.
Which mark?
How many questions?
I set one.
Just one, yeah?
That's it, just one, and a mark
And
one.
sub questions? No, one question you have.
One question. One question will be about the same thing.
What?
Is it multiple choice? Yeah, you said.
Yeah, you don't have to. I think there's 5 questions, and you got to do 4 or something like that. You don't have to do mine. There's others on the paper.
Okay, written question, but you can choose what to do.
You choose which one's on the paper. There's a number on the paper. One of them on the paper is from me. And there is enough on there to answer the question.
Get familiar with the figures.
Sorry?
Figures, tables, figures. It's asking the figures you have here in the section. Are you going to ask?
Oh, not the figures, no.
That's
It'll be a question, it'll be... The way I set the questions, I set a scenario, which is always something that I've met in real life, and ask you to answer it. So if you're cynical, you'll probably do well. I'm quite cynical. Well, you get stupid things, don't you? And it happens all the time.
So it's more like a practical
It'll be...
approach.
This is a scenario. Advise the client, or what advice would you give? And try and drop some stuff in from the lecture and from the notes.
Have you
It's
taught
not really
last
about
year?
like
Sorry?
Have you taught last year?
Last 15 years.
No, I mean the last year students. The last year
Yes.
freshman. You taught, yeah?
Yes. That's the last 15 years I've done for one question.
No, just to check, I mean, from
I'd black. There's past papers, yeah. They're all there.
Just helps.
I think they're all on the blackboard, aren't they?
Yeah.
Just to have an idea of
Yeah, just to have an idea how
Yeah.
the question is going to be.
Yeah, the past papers are all on the blackboard. I've got a business card if anybody feels the urgent need to get in touch, but my contact details are on the front of that. When's the exams? Is it early May, isn't it? 23rd. Yeah, I've got a bit of time.
On 23rd, it starts on 23rd, but this particular subject is going to be at the end of the May.
Yeah, it's the last exam, I think.
No,
It's not.
it's the third one.
It was the last one last year, so.
it was last year.
Is it all? We complete.
That's it, yeah. Unless there's any questions. I'll hang around for 5 minutes in case anybody's too shy. You don't need to. Previous years I've had to get signatures for who's attended, but I guess you've done it all there.
Can I get two more for my friends?
Can I have as many as I've got?
Okay, just two.
Just two.
If you don't mind giving me your, just in case. Just for help. One is. Oh, okay. Thank you. Thank you very much for the lecture.
When Nabil said because of those newts, the construction was delayed.
Yes.
What happened to the construction company? Do they get somehow compensated for the waiting time?
Yeah, well, it ended up in a big dispute because the client tried to say that you knew about where the site was. You should have known about them.
Yeah.
And they said, but it's your site. So there was a dispute, and it wasn't covered in the contract.
And because construction could say, I just said, why you didn't do
But
proper?
it said you have to comply with all legislation. But the legislation just said you don't have to disturb the newts. It didn't say you've got to stop and do all this. So eventually the contractor got paid, and it cost the gas client a lot of money.
So during the construction, they noticed
It was just during the construction I noticed. One guy noticed, and he was he liked wildlife. I do, so I'm not criticising.
So he was
He was one of the
construction.
he was actually driving one of the trenching machines. So he stopped, and but then what had happened? The contract, when he priced the job, he put very low rates in because he wanted to win the work. So then he was stood down. He said, "You've got to pay me because I'm stood down. All the men are just sat there and not doing anything." So there was an argument about that. But then he said, "Well, now I'm building in the winter and the ground's wetter. I was going to go and do another project, so I need paying more money for everything." And they said, no, we're going to pay you these rates. And he went to court, and the judge said, yeah, you've got to pay him, you've got to recognise that he's now doing something different to what was intended. So, but it was all down to who was responsible for the use. The judge said, well, it's your site, so you should have done an environmental impact assessment. Somebody pointed that out in the front row there. So, yeah. It cost a lot of money. It was only about a few £1 million. Where if we just walked the site, moved them all, could have gone straight through. There you go. So. Same with protesters. Come on and sit in front of the machine. Who's responsible? No, it's on the power station. If there's any protesters, the client takes responsibility. Because they didn't want somebody getting into a fight with the protesters. Bad publicity for them.
Thank you very much.
Okay.
Yeah, the business there.
Chad, yeah? So what did you do, P6?
I'm working as a project engineer in Qatar.
Ah, right.
Yeah. So I was closely with my project manager.
Yeah.
So I had been.
You need to do anything?
Okay, maybe I need to.
Yeah, I could go. I could download a lot of illegal software now and it'll over to your account. What do I do? Just log off?
Yeah, just close there.
That is?
That's what we can see. That's the plan. I think you left your USB.
Thank you.
Okay, no problem.
Perfect. This is Cherokee, and can I have your name card, please?
Go.
Thank
Can I
you.
get one more thing? For your nickname card. Thank you. Nuclear power plant company. Yeah,
At the minute, that's the client. It's EDF, nuclear new build. So, but I work for Faithful and Gould, so they second me down there. So for my sins. So I fly down on a Monday morning and fly back on a Friday night to Bristol. So my wife's not happy.
Actually, we work in shipbuilding engineering company, so most of contract we did was lump sum.
Yes,
lump
yeah.
sum.
Which is fine as long as you know what you're going to do. You specify it. You have all the and you say you go and do that.
Yeah, that's why we got many change order and.
Yeah. But if you have
extra
lump sum
cost.
and you start changing, which is what they try to do in the defence industry, they keep changing the technology. So well, there's one lump sum, and you can't move across. You can't track it. So well, we're going to give you a new lump sum now, and so basically you put a very low price in to win the work, and then you know they're going to change their mind. So then you put a high price in.
Actually, we started engineering only before, before we entered the company, so we should have listened to this lecture before we entered the company, and it was very beneficial.
You know, company Jacobs, their commercial manager talks to their engineers, and he says, "We are not here to do excellent engineering. We are here to make a commercial return." So he just tries to frighten all the engineers. But it's always money that people fall out over. Usually money, and time's the same. So yeah, very difficult. So where are you from?
From South Korea.
South Korea. Oh, some trouble there, isn't there?
Nowadays.
Your neighbour's getting upset with the Americans. Yeah.
Nowadays,
I think it's always been there, hasn't it? you know, for certainly in my lifetime.
Yeah.
So, do people worry about it, or is it just something?
Yeah, always we worry about our political issue in the world.
Yeah.
That's why.
But it's okay.
So how do you like Newcastle?
Ah, yeah.
Very
perfect.
like it.
Yeah.
We don't want to go back to Korea.
Could you understand it? Can you understand my English? Because we've got a strange accent in the northeast.
Probably I couldn't understand the most part because the material was very particular, so it was helpful to understand it.
I'm always impressed when you go around the world. Everybody speaks English.
Yeah.
And we don't speak anything. You know, we only speak English. We don't even do that very well. So.
So you are the English also.
Yeah. Well, English. It came from the German tribes came across to England and they landed on the beach at Northumberland. They were the Angles, which gave us Anglish, which became English.
English.
So yeah. So the Geordie accent is claimed to be, and the Northumbrian accent is claimed to be original English.
Of course.
So.
Well, thank you for your lecture.
Okay, you're welcome. Hope you enjoyed it.
Thank you.
Oh, your cap.
Yes. Thank you very much.
Okay, thank you.
Have a nice day.
Right.
Yeah. Here. Here. Right here.
여보세요? 된다. 야, 보고 싶어. 너 목소리에 왜 이렇게 힘이 없어? 상상하고 있어. 너 옷 입는 거 상상하는 게 왜? 왜 옷을 입고 있는 게 뭐가 이상해? 옷 벗은 거 상상한 거보다 낫지. 뭐 할 거야? 왜? 뭐 살 거야? 공평? 아, 그 여행용? 근데 가네. tempo. 빨리 가. 그래야 우리가 빨리 보지. 너 빨리 가서 파리가 가는 날 빨리 왔으면 좋겠다. 너무 예뻐. 나 이거 아닌데 너무 예뻐하네요. 딴 남자들이 본단 말이야. 그래 맞아. 뭐가? 딴 남자들이 연락을 해? 나 끊을게. 수업 갈게. 안녕. 내가 가서 검사해야겠어. 검사 안 해. 아니? 나왔는데. 통화가 안 터져. 아니야, 잠깐 나왔어. 인도 애들이랑 먹을 거야. 인도 여자애들이랑. 인도 여자 6명이랑 먹을 거야. 농담이야. 우리 과에 여자 없거든. 안 먹어. 프랑스 그 남자애? 잘 알 텐데 모르는 척하지 마. 나 아무것도 없었으니까. 진짜 아무것도 없었어. 억울해. 얘기했는데 걔는 진짜 아무것도 아니었다니까. 억울해. 난 수업 갈 거야 이제. 수업 시작했어. 응? 그래 공부 열심히 해야 되네. 공부할 거야. 안녕. 이제 갈 거야. 너가 나 보냈어. 저희 아니거든. 나는 뭐지? 모르겠어. 왜 웃냐? 넌 뭔데? 그래? 너 뭐 살림 차리고 싶다며? 차려? 아니? 차리자. 왜 못 차려? 한국에 한국 가야지. 하루에 안 가면 나 공부한 게 아무것도 소용이 없어. 논문을 내고 가야 돼. 왜? 가서 차리면 되지. 아니야. 영국으로 와 그럼. 내 방 있잖아. 내 방 커. 그래. 오늘 뭐 할 거야? 오늘 뭐 할 거야? 저녁에 어제 왜 아팠어? 술집이네 술집이. 어제 많이 먹었어 술? 응? 안 먹으면 되지. 왜 슬퍼? 좋아 먹지 마 이제. 나는 먹을 거야. 나만 먹을 거야. 헐. 내가 가만 안 놔둘 건데. 어? 가만히 있어라. 나 가만 안 놔둘 거니까. 귀엽네. 아, 나 빨리 보고 싶어. 조금이 아니야. 아니야, 많이 9달 남았어. 그래? 언제 가지? 내일 간다. 내일밖에 없어. 빈 시간이 없네. 이 수업을 많이 하는 거야. 예린이랑 놀 거야 오늘. 진짜 사이좋게 놀면 안 되죠. 화장할 거야? 왜? 원래 안 한다며. 해야지 그거. 오늘 상태가 안 좋나 보네. 너 원래 상태 항상 좋은데.
천장 다운로드 아주 칭찬해.